So in the last lesson, we talked about general solutions of differential equations. Now in today's lesson, we will talk about particular solutions of differential equations, and these are what we call initial value problems. So this means that from last time, we always have a constant c, or if it's a higher order differential equation, we have more than one constant. However, when we're solving for particular solutions, we know some other pieces of information which we can use to find out what those constants are. And so in the end, we only get one solution. So let's start by looking at the first question. Find the solution to the differential equation y dash equals 2x minus 3, where p, 0, 2 is a point on the curve of y. So, well, the solution to that would be the function in terms of x and y. So what I'm going to do first is integrate. So y dash, oops, I'm just going to change that into black pen. Y dash equals 2x minus 3. Y equals the integration of 2x minus 3 dx, which is x squared minus 3x plus c. Now, we know that p, 0, 2 is a point. So we know that when x equals 0, y equals 2. And so we sub that in. 2 equals 0 squared minus 0 plus c. Therefore, c equals 2. Therefore, the solution to the differential equation would be y equals x squared minus 3x plus 2. And you can always check it by doing what we did last time in terms of how we check the solution to a differential equation. So you can derive that and sub it into the original differential equation to see if left-hand side matches right-hand side. Okay, let's have a look at the next question. Consider y equals a sine 7x plus b cos 7x is a solution to the differential equation y double dash equals minus 49y. Find a and b if y 0 equals 1 and y dash 0 equals 14. Okay, so what does all of that mean? So here they've actually given us the solution, but it's a general solution and we don't know what a and b are. So what we can do is, in order to find out a and b, we need to use the information that we've been given. The first piece of information is this one here, y 0 equals 1. What that means is at x equals 0, the y value is 1. So 1 equals a sine 0 plus b cos 0. So 1 equals 0 plus b times 1, which is b. Therefore, b equals 1. Now, we are also given y dash 0 equals 14. So we need to derive the formula. So y dash equals, from this one here, I'm going to differentiate that. 7a sine, sorry, not sine, it should be cos 7x plus 7b sine 7x times by negative 1. So this here should be a minus. And now I know that we have at the point x equals 0, y equals 14, y dash equals 14. 14 equals 7a cos 0 minus 7b sine 7 times 0 is also 0. 14 equals 7a times 1, which is 7a, minus 0. So a equals 2. And those are the correct answers. Let's have a look at the next question. Differentiate both sides of x squared plus y squared with respect to x. Okay, so this question is asking us to differentiate x squared plus y squared, which is a little bit tricky, but we can do something called implicit differentiating. So implicit differentiation. What that means is we differentiate x squared as normal. So on the left hand side there we get, so I'm just going to write out the original first actually. So under x squared, if we differentiate that we get 2x plus. Now we differentiate y squared as normal, which is 2y, but we have to times that by what happens when you differentiate y in terms of x. So that's dy dx. And on the left hand side, if you differentiate 9, so if we had like dy dx of 9, we get 0. So that should be 0. So that's what we get. Now, show that dy dx equals minus x over y. So I'm just going to rearrange that. 2y times dy dx equals negative 2x. Therefore, dy dx equals minus 2x over minus 2y. Sorry, nope, not minus, just 2y. So that is minus x over y. And that is the gradient. So what that is saying is that minus x over y is the gradient for every point on the circle. Now for part B, where is the differential equation undefined and why is this the case? Okay, so a differential equation, so this time that is the same as, we can write that as y dash equals minus x over y. So when will this be undefined? Well, it'll be undefined when the denominator is 0, because that doesn't work if you put something over 0 in your calculator. So when denominator equals 0, so when y equals 0. Okay, so when y equals 0, it is undefined, and at which points would that be? So if we solve the equation, so at y equals 0, x squared plus 0 equals 9, therefore x equals plus or minus 3. So the 2 points are 3, 0 and minus 3, 0. Now, that is the correct answer because when something is undefined, it means that the gradient there can be a vertical line. And that makes sense in a circle because if I draw out the circle, you get something like this. So at 3 and minus 3, those 2 points, so 3, 0 and minus 3, 0, the tangent or the gradient at that point is indeed vertical, which is why when we put it into y dash equals minus x over y, the answer is undefined. So I'll say that they have vertical gradients, therefore dy dx undefined. Okay, and we will now talk a little bit about first order linear differential equations. So you can see in the name that it is first order, which means it should be no more than y dash and linear. So what that means is a first order differential equation is linear if it is written as y dash plus fxy equals g of x, where fx and gx are functions in terms of x. So I'll give you some examples. Some examples would be this one, so y dash equals 5x cubed, and we can also have other things like x squared y dash plus xy equals 0. as long as the y dash and the y are separate. So another example I can give you is y dash equals y over x, because that can be rewritten into the form like that. So this is our y dash is like that, and then fx times y is minus y over x, and the other side 0 is our g of x. But if we have this, that is not a first order linear differential equation, because if we rewrite it, we can actually put the y and the y dash together. So they cannot be together. So that is not a first order linear differential equation. And a special type of first order DE is actually this. So y dash minus ky equals 0, where k is a constant. Because this is actually an exponential growth, DE. But we will discuss this in a later lesson, so you don't have to worry too much about that. So the main takeaway from today's lesson are the particular solutions, which are also called initial value problems. So we did a few of those. Also, we did a problem where the differential equation, where the solution to that is a relation and not a function. So here, this is a solution of the differential equation dy dx equals minus x over y. But in this case, it is a relation, not a function. And we also looked at first order linear equations.